Good morning. I'm Mike Genest, and I'm Senior Vice President of Exodus Space. And I want to start my presentation by asking you to ponder a philosophical question. Do you think that we, the human race, is going to be satisfied to continue to put people and payloads into space on the pointy end of largely expendable single-use vertically launched rockets? Here's the problem. Despite the awe-inspiring and impressive advancements in launch vehicle technology by companies such as SpaceX and Blue Origin and others, launch continues to be complex, expensive, largely expendable, basically unsustainable in the long term. And we think that a growing and evolving launch market, with emphasis especially on evolving, is going to drive us to step up our game and improve things, as we've done with every other form of transportation in human history. It's time for a generational advancement. And here is our answer to that generational advancement question. A family of fully reusable, two-stage to orbit, horizontal takeoff and landing spaceplanes that we call the Astro Clipper series. Here's a basic mission profile. We'll take off horizontally from a runway. We'll climb and accelerate to a stage separation altitude. The booster will separate, turn around, come back, land on a runway. The orbiter will continue to orbit, conduct mission operations, initiate re-entry, come back for a gliding landing on the runway. The two vehicles will be turned around, reintegrated, and ready for launch. We anticipate being able to fly each individual space plane 10 times per year. So we are also aware, we're not the first company to say we can build a space plane and put it into operation. So what's different about us? Well, timing is everything, right? And for the first time, we've seen the availability of new innovations in aerospace manufacturing and technology that in combination make this a practical project. And the particular features that we intend to integrate into our vehicles include our patented aerodynamic inline staging configuration that you see here. We'll use non-cryogenic rocket engines that utilize jet fuel and hydrogen peroxide. We'll integrate advanced materials like carbon nanotubes into the vehicle. We will use 3D printing in the manufacturing process, and we will have AI-driven autonomous processes integrated into our flight software and ground software to help us with flight control, launch preparation, and post-mission diagnostics and turnaround. Now, the target market we're going to attack with these vehicles is the satellite launch, in-space services, and hypersonic research markets. You can see that those markets in combination are expected to top $200 billion by 2030. And we're only going to go after 3 subsegments of that overall market. And the vehicle we're going to do it with is the first and the simplest and smallest of our space planes. We call it the Astro Clipper Micro, which is an unmanned 500-pound orbit space plane that will be specifically purposed for the 3 most lucrative and currently active market segments. Those being microsatellite launch, hypersonic research, and space-based R&D. Those 3 segments alone approaching $100 billion in potential sales by 2030. As additional market segments in that overall market mature and become viable, we will develop follow-on vehicles in our series that are larger, more complex, to meet those markets as well. Now, we know that we are in a red-hot, crowded field of competition, but there's like 100+ launch companies right now either developing or operating launch vehicles, some of which are pretty heavy hitters, you can see. But the problem is most of these folks are developing the same kind of a launch vehicle, vertical rockets, not generally reusable, the same kind of thing that we've been fundamentally doing since the 1960s. And on top of that, only a handful of those competitors have actually ever successfully flown anything into space, and some of the others have some very unproven bleeding-edge technology in their critical path that's yet to be proven. None of ours are like that. They may be advanced, they may be state-of-the-art, but none of them are high-risk critical path technologies. And therein lies our competitive advantage. For one thing, we're going to bring a highly competitive cost to the market, very affordable, possibly best in class, and we'll also bring a combination of operational advantages that will allow us to operate and launch frequently, safely, to operate in spaceports worldwide with minimal ground infrastructure requirements. And we will be able to deliver and return down mass, down mass, down mass from any range of orbital inclinations ranging from polar to equatorial and everything in between. It sounds like a complex project, but we have the team to do this. Our leadership team here has over 130 years of combined experience in aerospace, technology, and entrepreneurship. And when you fold in our technical team, which has another extensive background in aerospace, encompassing the full program life cycle from R&D to operations, including aircraft, launch vehicle, and spacecraft programs, and in the government and commercial sectors, our team has the breadth and the depth to pull something like this off and make a success of it. We have LOIs for over 200 launches, and that keeps growing. We anticipate a 2-year backlog in launch services in the 2024 timeframe, leading to our first annual cash flow positive year in 2025, and we expect to go accumulated net cash flow positive by 2027. Currently, we are in a $15 million seed round that we will use to do in-depth feasibility studies and detailed conceptual design. We expect to raise that seed in stages, not all at once, unless somebody wants to write us a check for $15 million. And here's our longer-term development timeline that we're talking about. We've invested $300,000 in pre-seed, generating our basic concepts, doing technical and marketing research, and filing 3 patents and identifying future patent opportunities. And downstream, we have other series of rounds that we will use to complete the engineering development, fabrication, testing, and initial ops of our vehicle by 2027, begin development of the next vehicle. And I know what you're all doing. You're looking at that $700 million number at the top there. And boy, I've got some excellent comebacks or ideas to share with you about that. Why don't you ask me about it in a second? And in the meantime, I'm just going to ask you, please join us. We're going to bring launch into the future, baby.
So, two-stage to orbit is not a new idea. It's been around for a long time. I mean, NASA looked at the space shuttle being done that way. I guess on the technical side, my questions would be, you're obviously developing this as a full-up integrated 2-stage system, so you're not just developing the booster, you're developing the upper stage as well. What kind of altitude and velocity does your first stage get you to before you release the second stage?
We've done some initial and analytical takes at that, and we think we can achieve a stage separation at about between 50 to 60 nautical miles in altitude, and we're hoping to approach Mach 8 to Mach 10 in velocity.
So you're going to need a TPS on both stages then?
Yep.
How are you planning on doing that? The TPS is probably more difficult than building a rocket engine.
Yeah, we realize that, and that's one of the things that, we said in the seed round, we're going to use those funds to staff up some engineers and do some feasibility trade studies, and then move on to more conceptual design. And that's the point where we really begin to drill deep into the available technologies and some innovative concepts for tackling that problem, and a range of others that we feel are the most critical problems that will lie on our critical path, technically speaking.
Curious, with that large funding that's going to be required, what you foresee as your early revenue opportunity. You have licensing and you have patents. Are you going to be licensing? I mean, this is unique technology, but I'd love to know, you do need some early wins, so maybe you can share what those might be.
Well, thank you for that. Yes, and I'm gonna have my co-worker here. This is Frank Trevino. He's our Chief Marketing Officer and our artificial intelligence expert as well. And you're right, we have a variety of terrestrial spin-off opportunities. There are exit points all along that sequence that I showed you on that last slide there. And also, there's also the possibility, even the probability, that through acquiring government funds and or early customer revenues, we can either significantly reduce or even eliminate some of those larger, out-year funding rounds. But in terms of specific spin-off opportunities, AI jumps out as one of the key possibilities. And I'm going to let Frank talk about some of those possibilities.
We just kind of look at it from how do you self-diagnose, self-heal, and self-orchestrate from an AI perspective. And as we start looking at that and start building it, we're thinking about how do we have embedded IoT devices, how do we use machine learning, visual, computer vision, How do we apply some of the tactics that are being used in manufacturing today and apply that to the vehicle itself? And we believe that as we go through this process and we start developing some of this IP through the AI, that we're going to license that back out, that we're going to figure out how do we leverage that IP to help offset our costs in initial stages with that. And we think software is the best bet because it's software. It's easier to develop versus engines or anything else. We also have the IP on the inline design that we're exploring too to see how we leverage that in the future.
And I might also, even as early as the end of the conceptual, the seed funding round, what we expect to complete with this detailed conceptual design, there's probably a saleable product right there. If there's somebody else that wants to develop a space plane and they realize that we have solved some of those problems like you asked, the TPS problem, somebody may want to buy that design off of us right there. It is an early exit point. Not that I'm saying we want to do that. We want to keep going and become the Southwest Airlines of space planes. But I'm just saying there are opportunities all along the way.
I was curious, as you've mentioned a couple of times, $700 million is a lot of money, and you mentioned that you were going after government money potentially. It seems like you would probably have to at that price range. Can you give more details about where you're planning to go to get that kind of level of funding?
Okay, yeah, you're the guy. Well, we know a guy from the White House who can help us with that. No, but actually we're starting small and humbly with SBIR grants with both the DoD and with NASA. We can begin to pathfind our way forward, government contacting, networking that way. We have some board members who, I can't say their name because they're waiting for us to get funded so we can buy some, DNR insurance to protect them. So we do have networks that are kind of helping us begin to infiltrate into government contacts. Beyond that, though, if we can get to the point where we can fly a prototype, the old saying, if you build it, they will come. We feel that we will be in a position to compete favorably with future launch service requests from the contracts from the government, or even in a position to provide commercial services to the private sector.
So just following up real quickly on that, what's the smallest prototype that you guys are thinking of, and when would that be schedule-wise?
Yeah, the first vehicle I mentioned is we realized we couldn't go straight to our big human-rated version at the end. So the very first vehicle is what we call the Astro Clipper Micro. It's a small vehicle. I can't give you the exact dimensions. We're still trade studying that. But it's, like I said, 500 pounds to low Earth orbit, unmanned, and we would expect that to be operational in the 2026 timeframe.
And on that point, the unmanned being your first mission, do you have a regulatory pathway? Are you involved right now with the daily changes going on with space policy to make sure that their pathway exists for your unmanned test?
Yes, that's an excellent question. Two answers, I can think two ways to answer that question. One is among our team of advisors, we do have people with FAA experience who can help us navigate those pathways. We can hire who we need to hire when the time comes to cross some of those thresholds. And because we don't anticipate being really operational with this for another, until like 2026, the mid-20s, we expect other companies are going to break some trail for us. Because there are people developing spaceports all over the place. People are going to start operating out of them. Virgin Galactic will start doing suborbital stuff. We expect some regulatory and trail breaking to happen with other companies that we can leverage.
So, first, wow, what an amazing vision.
Thank you.
Sitting in a little town in Warrenton, Virginia, is a series of prototypes that Grumman did when they envisioned this back in the shuttle days. So I'm excited by the vision, but I share some of the skepticism that I think my fellow judges share in relation to how do you get there. It seems like you need an Elon. Elon took on something that people were not at all sure could be done, and he really accomplished something spectacular. Love to find a way to help you get there, because for the nation and humankind, it's really important. So is there a question on all that? I think the question is, and people have been getting at it, can you really get enough private financing to get far enough along to be able to convince the government to bring major funding to get you to where you need to get to? Do you have some, you gave a few thoughts, but you got to get specific on that. And what I haven't seen are the numbers that would make those of us in the private equity side or the venture capital side feel comfortable doing that. So how do you get that comfort?
Yeah, that is a really juicy question, and I think it would, it's worth a long, extended meeting around a table with some really deep and insightful research in advance, so we can plot a detailed path forward. We know VCs are not going to just go, oh yeah, that's cool, let's write you a check. We know it's rigorous, and we're prepared to go through the process. We will add team members as we need to achieve that. And we are more than ready to do whatever it takes, to work as hard as it takes, to get the answers to those kind of questions in the fullness of time so that we can get there.
And to add on to that, I think another piece is gaining traction on the grant side. Going back to the government, I think that's where we're going to build that credibility, being able to get some of those on the investor side to say, the government's looking into us, they're investing into this. How will the investors themselves come in to look into that too?
Thank you.
Mhm.